Here we are in Algebra 2, Section 5-7, Rational Expressions. Something that we need to remember. Rational expressions, hopefully you remember this, are just fractions. So we call a number like 4 over 3 a fraction or a rational number. Any number you can write as a fraction is rational. So when you have an exponent that's a rational number, or a fraction, we could write it as a is equal to, a to the m over n is the same as the, peep this, the nth root of a to the m. So this is like key. It's like holy grail. We need to keep this in mind. Generally, in this section, we're going to see a to the 1 over some value, let's say n, and what that means is that's the nth root of a. If we have a numerator other than 1, then that value is going to be the exponent of the thing under the radical. Hold on to this. We're going to use this in the next few problems. So the first thing we're going to do is just learn to rewrite these things in radical form. So if I have a to the 1/4 power, according to my rule up here, I know that this is just the 4th root of a to the 1st power, or just 4th root of a. Here, similarly, x to the 1/5 power would be the 5th root of x. Pretty neat, huh? In example 2 here, I'm now going to take this rational form and I'm going to change it to this radical form, and I'm going to change it to a rational exponent. So we look at this guy and we recognize that this really just means y to the 1/3 power. And here, this just means c to the 1/8 power. Notice the index number is always the denominator. There are a couple of ways of looking at these problems. The first thing you want to do, so we're going to look at 2 different methods or 2 different approaches. The first thing I'm going to do in this method here is I'm going to decide to acknowledge that this is to a negative exponent. Do you remember what we did with our negative exponents? I hope you do. Negative exponents mean you drop it into the denominator. If it's in the numerator and you bring it up from the denominator, you bring it up to the numerator if it's in the denominator. So here, I recognize that 16 to the negative 1/4 is also, or can also be written as 1 over 16 to the 1/4 power. And we know that the 1/4 power means the 4th root of that number. So the 4th root of 1 over 16 is really the 4th root of 1 over the 4th root of 16. The 4th root of 1 becomes 1, and the 4th root of 16 becomes 2, and we're done. So this one, in this method, we use like radicals. We change it into a radical to kind of think through it. But notice we also use exponential laws. Let's try a different way of doing this problem. So again, I'm working with 16 to the negative 1/4, but instead of breaking this down and changing it into the radical, I'm going to honor the fact that I'm dealing with exponents, and I'm going to write 16 as, in its exponential form, 16 to the 2/4 power. So 16 is 2 to the 4th power, rather. And so now that I've got 2 to the 4th power as 16, I'm going to put my 1/4 right out there. Do you remember what I do when I have a power raised to a power? It was the rule a to the m raised to the n power. We multiply those 2 powers to get a to the mn. We're going to do the same thing here. When I multiply 4 times negative 1/4, I end up with 2 to the 4 times negative 1/4 would be 4 over 4, negative 4 over 4. I get negative 1. And we remember what this means. If you have it to a negative power, some number, it's now going to be put in the denominator. So I end up with 1/2. Same answer. Oftentimes, you might see a problem one way and not see it another way. It's okay. Knowing that you're doing the right thing just really means that you are following the laws. You may not do it the quickest way, like this wasn't that quick, this was a little quicker, but once you follow the laws of exponents, you'll be fine. Let's look at another example. So looking at this problem, I recognize that we have 243 to the 3/5 power. So what I might do is say, okay, let's change this to the 5th root of 243, and I'm going to raise that to the 3rd power. The next thing I want to do is think about breaking this down into a prime factorization. I see I have 243. I know 3 can go in that to that easily, and when I divide 3 into there, I end up with 81 times 3, and 81 can be broken down into 9 times 9. And if I break this down completely, I'm going to get that this is the 5th root of 243 is 3 to the 5th power raised to the 3rd power. And since I've got like 3 to the 5th power times 3 to the 5th power times another 3 to the 5th power, hence 3 to the 5th power to the 3rd, and I'm taking the 5th root of that, then I end up with the 5th root of 3 to the 5th times the 5th root of 3 to the 5th times the 5th root of 3 to the 5th, tongue-tied. I end up with 3 times 3 times 3, which is 27 as the answer. If I consider a different method, I'd start off kind of similar, thinking about this guy, 253, write it as a power. So 3 to the 5th power is what 243 is, rather. And then I'm raising that to the 3/5 power. Notice the only thing I did is change the 243 to 3 to the 5th power. Now we're going to take on that rule again, power to power. What happens when we take a power and raise it to another power? We are multiplying those exponents. So I've got 5 over 1 in a way, times 3 over 5. 5's cancel. I end up with 3 to the 3rd power, and I get 27. Now that was fast. Let's look at another example. Here we have an equation or a formula within a word problem that's going to ask us to use some of these funky exponents or these rational exponents. The problem reads, the formula m equals 512 minus 146,230 times b to the negative 8/5 power can be used to estimate the maximum total mass that a weightlifter of mass b kilograms can lift in 2 lifts, the snatch and the clean and the jerk combined. According to the formula, what is the maximum amount that 2000 Olympic champion Zhuang Zhang of China can lift if he weighs 72 kilograms? Well, this is pretty straightforward. What we're going to do is just substitute it right in to the formula that we're given. And so when I do that, I get my 72 here, and I've got to multiply it after I raise it to the negative 8/5 power. This is a great calculator problem. You're really just plugging it into your calculator. And when you do that, approximately 356. Now that you have this, we're going to answer the next question. 356, kilograms. The next question asks us about Zhuang Zhan's winning total in 2000 being 367.5 kilograms. Compare this value to the predicted value. Well, it looks like the predicted value is lower than the actual value. It was close, but it was lower. So it looks like the predicted value was an under prediction according to the way that this gentleman performed. And that's how we would answer that part. Let's look at another question. So when simplifying these expressions, or in this case multiply, we're going to multiply like we did last time. Remember, a to the m times a to the n was equal to a to the m plus n. With that in mind, we're going to add exponents in the way that we added them here. So x to this power times x to this power, two numbers with the same base, we can add the exponents. We're going to get x to the 1/5 power plus 7/5 power. And so we get x to the 8/5 power. Simplify the expression with rational exponents. We've done our job. We're done here. Let's go ahead and take a look at this guy. Over here, to simplify this guy, the first thing I want to do is honor the fact that it has a negative exponent, and I'm going to drop it into the denominator. So I'm going to get 1 over y to the 3/4 power. At this stage of the game, I've got 1 to the 3/4 power in my numerator, which is just 1 over y to the 3/4 power. I could stop here, but if you remember, this would really be like a radical expression in the denominator, and we like to not have radicals in the denominator. So what do I do? In this case, I am going to multiply by a 1, but I'm going to multiply by y to the 1/4 over y to the 1/4. Let's think about y. The fact is, when I add 3/4 plus 1/4, I'm going to get a whole number exponent. And that means I'm going to get a whole number value. That means I have no fractional exponent, which we know is a radical. All right? Think about what that would mean. If I had this problem right here, it would be the 4th root of y to the 3rd power. That's unresolved. Here, I would have the 4th root of y, and look at that. Y to the 3rd times y gives me y to the 4th, which resolves my issue. Now, I'm not going to do that. I'm not going to write it in radical form. Instead, I'm going to honor this new form, this rational exponent form, and I'm going to say, oh, I want to make sure I get values that will add up to the number 1 in terms of the exponents, or a whole number rather. So when the numerator is going to be y to the 1/4 power, whereas my denominator will be y to the 4/4 power, which is just y to the 1, or just y. And then at the top, I have y to the 1/4. And that's how I'm going to leave my answer. Example 6 gives us an opportunity to simplify. So we have this opportunity to change it into a rational expression. But first, let's break it down as far as we can go. I know that 81 is 3 to the 4th power. And I can not do any more with this 3 down here. What I'm going to now do is write them as rational exponents. We remember, if I had the nth root of a to the m, that's equal to a to the m over n. Notice the denominator is always the index number. So here, I've got 3 to the 4/8 power over 3 to the 1/6 power. The beauty in this is that now I've got the same number with different bases. Same base, same number that has the same base, same number as the same base with different exponents. I can subtract those exponents. And I get 3 to the 4/8 power minus 1/6 as my final answer. I'm going to rewrite this differently. 4/8 is another way of saying 1/2, and I can write 1/2 as 3/6 minus 1 over 6. And I'm left with 3 to the 2/6 power, which can be reduced to 3 to the 1/3. And that's my final answer for this one. Let's take a look at this next section. This guy I'm going to rewrite as the 4th root of 3 squared z squared. And so I know that this is 3z quantity squared, right? Taking the 4th root of that. So I could write this as 3z to the 2/4 power, or 3z to the 1/2 power if I reduce that. I could stop here and leave it like this, or I could actually return it to radical form and write it as the square root of 3z. The next problem we're going to look at has an interesting look to it. I've got m to the 1/2 minus 1 over m to the 1/2 plus 1, and basically we have a radical in the denominator. I'm going to multiply by a gourmet or a tailored 1, and that 1 is going to be the conjugate of this guy, because really this is the square root of m plus 1, the conjugate of which is going to be square root of m, or m to the 1/2, minus 1. And so I'm going to multiply top and bottom by the same thing. I got to FOIL it. M squared times m to the 1/2 times m to the 1/2 is m. M to the 1/2 times a minus 1 is a minus m to the 1/2. Minus 1 times that. And after that, I'm going to basically get this as my answer. The denominator has no weird exponents or radicals, so I'm going to simplify by joining these guys together. And my final answer is m minus 2m to the 1/2 power plus 1, all of that over m minus 1. Here's a suggested assignment. Page 261, 21 to 63 odd.